Hello everyone, today I am back with another video. My name is Rakshita. I am studying in Sri Venkateshwara College of Engineering 3rd year from the Department of Electronics and Communication Engineering. Today we are going to discuss about the subject called microwave and antenna. So let's see what is microwave tubes. Microwave tubes are the structured tubes used to generate the amplified signal. The frequency ranges from 1 GHz to 10 power 6 GHz. So now let's see some advantages of microwaves. The first advantage is less fading effect. Fading effect is less at high frequencies and more reliable communication. The next advantage is power requirements are low. Transmitting and receiving power requirements are pretty low at micro frequencies compared to that of other bands. Increased bandwidth availability. Microwave have large bandwidth. The information transmitted in this frequency range is more. Hence, microwave are used in various long-distance communication applications such as telephone networks, TV networks, space communication, defense, railways, and etc. So now let's see some application of microwaves. The first application is telecommunication. It is used in telephone exchange and TV space communication, etc. The second one is radar. It is used in air traffic control, garage door operators, police speed detectors, etc. And the next application is commercial and industrial application. Like example, micro oven, drying machines, food processing industry, etc. In this we can see the types of microtubes. The first one is linear beam tubes. The second one is cross field tubes. Under linear we have klystron and slow wave structure. Under cross we have magnetron and etc. So now let's see reflex klystron. This is the diagram of the reflex klystron, and now I will tell the working about the reflex klystron. Reflex klystron is microwave oscillator. Reflex klystron works on the principle of velocity modulation of electrons in repeller space. The structure of reflex klystron consists of single microwave cavity with gap, cathode plate, focusing electrodes, repellers. Repellers is connected to negative terminal of repeller voltage. Reflex klystron consists of two batteries, namely first one anode battery. The second one is the repeller battery. The anode battery, the beam voltage and is connected to the anode cavity, and its negative terminal is connected to cathode plate. The reflex battery, repeller voltage negative voltage connected to the repeller plate. Working of the reflex klystron. Consider three electrons, early electrons, reference electrons and the late electrons at the starting point of the gap from the repeller side. The electron gun emits electron beam towards the anode cavity. The electrons, after passing the gap in the cavity, travel towards a repeller electrode which is at high negative potential. The electrons will never reach the repeller because of the negative field and are returned back towards the gap. The repel back to the anode cavity due to high negative field. The electrons give more energy to the gap in their return journey and their oscillations are sustained. The RF voltage that is produced across the gap by the cavity oscillation act on the electron beam to cause velocity modulation. The reference electron passes through the gap when the gap voltage is 0. They are not affected by the gap voltage. They move towards the repeller and gets reflected by the negative voltage on the repeller. They return and passes through the gap. The early electrons that passes through the gap before the reference electrons experience a maximum positive voltage across the gap and their electrons are accelerated. They move with the greater velocity and penetrates into the Repler space. The return time for electron is more as the depth of the penetration into Repler space is more, hence early electron and late electron appear at the gap at the same instant the rate electrons that passes the gap later than the reference electron experience a maximum negative voltage and moves with retarding velocity. The return time of all these electrons is less and catches up with early electron and repair electron and forms a bunch. Let us see one numerical on reflex klystron. The reflex klystron operates at mode with beam voltage 300 volt, beam current 2 milliampere, signal voltage 40 volts for mode number n is equal to 2. Determine output power, input power and efficiency. This is the problem statement, and now let us see the solution for the given problem statement. So now the given data is V is equal to 300 volt, I is equal to 20 milliampere, N is equal to 2, X dash into J1 X dash is equal to 1.25. This is constant. To find out the output power PAC, we need to consider the formula 2 into V naught into I naught into X dash into J1 X dash divided by 2AN minus pi by 2. And to find the input power PDC, we should consider V naught into I naught. By substituting all the given data in PAC and PDC, we get the required answer. By substituting the given data in PAC, we get 1.366 watts, and by substituting the given values in PDC, we get 6 watts. To find the efficiency is given by PAC by PDC into 100. By substituting the PAC and PDC value, we get 22.76%. So thank you all for watching my video. Please do like the video and subscribe to my channel.